In this movie, the first thing I'm going to do in starting to create this terrain project is to create the movement of the player. So here we have this capsule object which represents the player in the scene. I'm just going to select this object, and you can see that we have three objects that is ultimately composed from. We have this player object here, which is in fact an empty game object, but it has a capsule collider component attached that approximates the shape of this mesh. Underneath this, we have a capsule object in the scene, which effectively represents a capsule mesh, except that it has the collider component removed. I have added the collider component to this player object instead, because this is the object to which I'm going to be attaching the script. The third and the final object that we have is a raid test object. Again, this is a completely empty game object that you can see that we have here with the forward vector aligned forwards. It's a completely empty object that I've simply put at the front of this object in relation to the parent, which is this player object here. So this empty game object is going to be useful later, but we don't need it right now. But you will need to go ahead and create that empty object if you are following along from scratch. So I'm going to go back to the player object here, and I'm going to be creating a completely new script file for this object that is going to encode the basic movement of the player. So to do that, I'm going to move down here to the project panel and right click and choose create, and then choose C# script from the context menu. I'm going to name this script terrain hover and then press enter on the keyboard here. I will simply double click on this script file to open it inside Mono Develop, so you can see that I have the script file here. Now we need to create some initial variables. For example, we're going to need to access the transform component of the object. So I will need a private variable for the transform component, which is going to be private transform, and I will call it this transform, like so, and press Ctrl S to save that here. Now I'm going to get access to the transform component inside the awake function, which is called at the level beginning. So I'm going to choose the awake function, and inside them I'm going to get access to the transform component, as we've seen many times before with get component transform. So I'm just going to select the transform class, add that here. Now in addition to this, we're going to need to read input from the keyboard here, and I'm going to use the cross-platform input manager to do that. So in other words, I need to come up here to the top of the source file where we have using Unity Engine, and I'm going to need to add that in. So I'm going to be using the Unity standard assets, which you can find down here on the bottom of the list in the code completion dialog. I'm going to select Unity standard assets. I'm going to press dot, and you can see here we get a range of different kind of classes that we can use, or namespaces. I need to use the cross-platform input one here, so I'm going to complete that line there and put a semicolon at the end of that line to complete that statement. Now I need to read input from the keyboard inside the update function here. So again, I'm going to create two variables to do that. The float horizontal variable, which is going to read input from the horizontal axis. So I'm going to choose get axis, and I'm going to name this horizontal, like so. And I'm going to grab that line and simply paste it to read data from the vertical axis. That's the up and down axis, or the up and down keys on the keyboard. So that represents the vertical axis here. Now, in response to that player input on the horizontal and the vertical axis, I need to transform the capsule object. That is, I need to move it around in the scene. And to do that, I'm going to be using a vector. So what I'm going to do here is grab a new vector by choosing vector 3, and it's going to be the new pos of the object. I'm initially going to set that to whatever our position is. So wherever the object is right now, I'm just going to take a copy of that position into the new vector here, and I'm going to create an offset for that. So the new position is going to be equal to itself plus the new displacement. Now for the vertical input, we want to move forwards and back. So we're going to displace it by the input amount on the vertical axis. So that's going to be this transform dot forwards, and notice I'm using the forward vector as expressed in world space this time. I'm going to multiply it by the vertical input, which could be -1 if we're pressing down, +1 if we're pressing up, and 0 if we're pressing nothing or both up and down at the same time. So I'm going to multiply that by our maximum speed. Now I appreciate we don't have a maximum speed variable yet, which is why MonoDevelop is highlighting that variable in red, but we're simply going to add one. I'm also going to multiply that by time.delta time and then complete that statement. Now, of course, we don't have a max speed variable, so let's add one at the top here. So I'm going to choose public and float, and I'm going to give this a maximum speed. I'm going to give this the initial speed of, say, 10, that is 10 meters per second. And as soon as I add that variable max speed, notice that the code becomes correct further down here. Now, of course, we also need to create displacement, not just for the vertical axis moving forwards and back, but also for the horizontal axis moving left and right, which means we're going to need an additional displacement here. So I'm going to choose new position plus equals, and in this time we're going to move, that is, in the direction of the right axis. So whereas moving forwards and back was using the forward vector, we're now going to use the right pointing vector. So I'm going to choose right multiplied by the horizontal input multiplied by max speed times time.delta time. And there we have completed the basic position data for this object. We can test this code easily by choosing this transform dot position equals the new position. This isn't necessarily going to be the final code, but this is just to test the displacement so far. So I'm going to press Ctrl S to save that, close this code, go back to Unity and press play on the toolbar here. Actually, before I press play, I have to select the player object and make sure that the hover script is attached. So I'm going to drag and drop the script onto the player object here and confirm this by looking in the object inspector when the player is selected, and I can see that the terrain hover script has been added. So I'm going to press play on the toolbar, and when I do that I can move forwards and back and move left and right. Of course, notice right now it doesn't take account of the terrain at all. That's absolutely fine. We just want to get our basic movement in place, and there we have it. It's already in place, but we still need to move on and actually make this object conform to the terrain, and we'll consider that next.